y equals f of ax. So this a here represents a horizontal compression along the x-axis. So we want to see what does that do to the derivative and the slope function. So we're going to start with y equals sine x. So there's our sine graph. And we're going to compare it to y equals sine of 3x when we have this horizontal compression. So it's going to compress horizontally 1/3 towards the y-axis. So here's our y equals sine 3x in blue. In red, there is a y equals sine x. And we can see that 3, if we compare these 2 points here, that 3 is a horizontal compression of 3 times towards the y-axis, okay, or a compression of 1/3. So what does that do to the slope? Well, if I take a look at a slope triangle and I compress this slope triangle by 3, what ends up happening is this triangle slope gets 3 times bigger. Okay, so there's our original. We compress by 3. Our horizontal compression results in a 3 times expansion or 3 times increase in our slope. So this horizontal compression then has to be accounted for in our derivative. So the 1/3 compression gives us a slope of 3 times bigger. So to accommodate that or account for that, what we do is when we differentiate the sign, we end up with cosine, but that extra 3 then has to be multiplied onto the derivative to account for the 3 times bigger slope that we're getting. So this is how we deal with this horizontal compression. Later on, we're going to use something called the chain rule, but for now, we're going to use, when we see this horizontal compression, we just have to remember to account for it with a times 3. So we generalize this then, for any horizontal compression, we take the derivative and times it by that horizontal compression factor. So an example here is y equals ln of 4x. If I want to differentiate this, y prime is going to be equal to, well, the log function is 1 over x, so I do 1 over, and the whole argument is 4x, so I put the whole 4x in the bottom. But because of that horizontal compression of 4, we need to account for that horizontal compression by multiplying everything by 4. And so we end up with y prime is equal to, well, the 4's do end up canceling out, so we end up with 1 over x. So that is our derivative function of y equals log 4x. Now you may notice that this happens to be the same as the derivative of 1 log of x. So how does that 4 factor in there? Well, we can actually show this as an alternative. And we can use log property to show that 4 actually doesn't really affect the slope. So if I use log rules, I can split off that 4 from the x by using the log property, where I can add logs is multiplying the arguments. And when I differentiate this then, log 4 differentiates to 0. It is a constant. The log x differentiates to 1 over x, and then I end up with the same expression. Now this only happens for logs. This is a unique property of logs, but we can separate out that constant term as a plus term, which then differentiates to 0. But again, in general, if we have a horizontal compression, we have to account for that horizontal compression by multiplying by that horizontal compression to account for that.